Hello guys, I am Mowli from Mechanical Engineering, first year in IARE College. I want to tell about now loading series in load sharing in series and parallel circuits. In field of electrical engineering, understanding how load sharing works in series and parallel circuits to fundamental to analyze and designing circuits. The configuration of these circuits determines how current and voltage behave across the components and how power is dissipated. The two primary types of circuits configuration and series and parallel, each offering unique characteristics and behaviors, particularly when it comes to load sharing. First one is the I want to tell about first about series circuits. Series circuits is nothing but is a type of circuit where all the components such as resistors, capacitors or inductors and connected end to end forming a single continuous path for current to flow. In this type of current, the same current flows through all components since there is only one path for the flow of electronics, and the current is determined by the total resistance of the circuit and the applied voltage. The relationship is given by Ohm's law, where I is the current, V total is the total voltage, and R total is the total resistance. The total resistance is a series circuits in the sum of individual resistance of components connected in series. The voltage across each resistor in the series circuits is proportionally to its resistance. Using Ohm's law, the voltage drop across each resistor is given by V is equal to IR, where I is the constant current. The voltage across the series circuits is the sum of individual voltage drops. V total V plus V1 plus V2 is equal to Vn. However, one of the major disadvantages of a series circuit is that if any one component fails, for example, if a resistor burns out, the entire circuits will be interrupted and no current will flow through circuits. This is because there is only one path for the current to flow, and a break in the path cause the current to stop. And the next one I want to tell about parallel circuits. A parallel circuits is nothing but in construct connects components across the same 2 points, creating multiple paths for current to flow. Each component is connected directly to the voltage source. So the voltage across all components in a parallel circuits is the same unlike in series circuits. The current in a parallel circuit divides among the components based on their individual resistance. In a parallel circuit, the voltage current is the sum of currents through each parallel branches. According to the Ohm's law, the current through each branches can be calculated as I is equal to V by R, where V is constant voltage across each branch and R is the resistance of each component. The current through a component with lower resistance will be higher, and the current through a component with higher resistance will be lower. This is another form of load sharing as the total current is distributed among the components according to their resistance values. For example, if there are two resistors in parallel with resistance R1 and R2, the current through each resistors will be I1 is equal to V by R1 and I2 is equal to V by R2. The total current in this circuit is the sum of the individual currents. I total is equal to I1 plus I2. One of the major advantages of parallel circuit is that if one component fails, the rest of the circuits continues to function. This is because this failure of one component does not affect the current flowing through the other branches. Therefore, parallel circuits are more reliable and were widely used to household electrical wiring system. For instance, if one light bulb is in parallel circuits burns out, the other light bulbs continuously function without interruption. This feature makes parallel this feature makes parallel into circuits are more reliable and widely used parallel circuits. The function without interruption. Electrical appliances are systems that requires continuous operating if even one component fails. And additionally, in parallel circuits, the voltage across each component to the same. This means that each component receives the full voltage of the power sources, which is particularly important in system where uniform voltage across component is required for properly operation. In contrast, in a series circuit, the voltage is divided among the component which may not be desirable if all components need the same voltage for proper functioning. Comparison of series and parallel circuits in load sharing. In a series circuit, load sharing occurs in the form of voltage division where each component experiences a different voltage drop depending on its resistance, and the current remains the same throughout the circuit, but component with higher resistance sharing a large portion of the total voltage dissipate more power. However, since the circuit is the same for all components, the failure of one component can disrupt the entire circuit, leading to system failure. And the next, in a parallel circuit, load sharing happens through current division happen and each branch receives the same voltage, but the current through each branch is inversely proportional to its resistance. Components with lower resistance draw more current while components with higher resistance draw less. The current division is crucially for efficiently distributing the electrical load among multiple components. Furthermore, parallel circuits are more reliable because the failure of one branch does not affect the rest of the circuits, making them more suitable for most practical application. Overall, while sharing circuits are simply to design and easy to analyze, these are less efficient in terms of load sharing and have the downside of being vulnerable to component failure. On the other hand, parallel circuits are more flexible, efficient, and reliable for load sharing, making them the preferred choice in many electrical systems, from household wiring to complex industrial circuits. Here are my all PDF pages about this presentation. Thank you.